This is going to be our second video on electrochemistry, and here we're going to continue with our discussion of redox. I'm going to show you how to balance oxidation and reduction reactions, which is a little bit more complicated than balancing other types of reactions, because we have to balance both the charge and the mass. So the first thing we're going to do is divide our reaction into two separate half reactions, what we call half reactions. One for the oxidation and one for the reduction. Okay? And the second step, we're going to multiply each half reaction by some integer so that the electrons balance. Okay? And then we add the balanced half reactions to get an overall unbalanced equation. It'll be balanced for charge, but unbalanced for mass. So what we're doing in these first three steps is balancing the charge. Remember what I said about why oxidation and reduction always have to occur in pairs. You can't have a reduction without an oxidation, because electrons are consumed in a reduction. Where are those electrons coming from? They're coming from an oxidation reaction, right? But the electrons have to balance. And that's what we're doing in these first three steps, is balancing the electrons transferred. Okay, then our fourth step is to balance the mass. Okay, so we can balance the mass two different ways. One for acidic solution and one for basic solution. So if our reaction has taken place in acidic solution, then we can add hydrogen ion or water as we need to balance the mass. So let's say that we need to add oxygen to one side of our equation to make the mass balance. Then we would add water to one side of the equation, and we'd add two hydrogen ions to the other side to keep the hydrogen balanced. Okay? Or if we're in basic solution, then we can add water or hydroxide ion as we need to balance the mass. Okay? So let's work an example. Alright? So let's look at this reaction. The reaction between permanganate and iodide to form manganese dioxide and iodine. Okay? So before we even get into this, we have to first, before we can start to talk about what's the oxidation and what's the reduction, we have to figure out the oxidation numbers. So let's look at MnO4 minus. One more time, that's the permanganate ion. Okay? Well, if oxygen is always going to be -2, and we have a charge of -1, right, then you should be able to see that that's manganese with an oxidation number of +7. If we go to iodide ion, that's a monatomic ion. That's a monatomic ion, so the oxidation number is the same as the charge, so that's -1. All right. Manganese dioxide, if oxygen is -2, right, that's -4, so the manganese is in the plus, has an oxidation number of +4, right? And this is molecular iodine, or I2, which is iodine in molecular form. Anything in elemental form has an oxidation number at 0, right? So you should be able to see from permanganate to manganese dioxide, that's a change in oxidation number from +7 to +4. That's a reduction, right? That's the definition of reduction. It's a decrease in oxidation number. Okay? And here we're going from -1 to 0, right? That's an oxidation. And that's the definition of oxidation. That's an increase in oxidation number, right? So our first step then is to divide this into half reactions. And now we've already identified what's being oxidized and what's being reduced, right? So the reduction of permanganate to manganese dioxide is basically going to involve 3 electrons, right? From +7 to +4 is a change in oxidation number of 3. Remember that electrons are consumed in a reduction reaction, so they go on the left side of the equation. So electrons are consumed. Okay? So our oxidation number, or oxidation reaction rather, is iodide becoming iodine. Now, it's okay when we write equations like this, it's okay to do a partial mass balance. Because I2 is a diatomic molecule with 2 iodines, I'm going to put a 2 here and make this 2 electrons, okay, to keep the iodine balanced. Don't worry about balancing oxygen or hydrogen. We'll do that at the end. But anything that's not oxygen or hydrogen, we can balance here. So 2I2, 2 iodides become an iodine and 2 electrons. Okay. So then our third step is we're going to balance the electrons. In other words, we're going to combine these into an overall equation that's going to be balanced for charge. Right? So to make the electrons balance, okay, we have 3 transferred here, 2 transferred here. The lowest common denominator between 3 and 2 is 6, right? So we're going to have to multiply this reaction by 2, okay, and multiply this reaction by 3, okay. And so we do that, okay, and that's going to give us these equations, right? So we've multiplied this first reaction by 2. So now we have 2 permanganate ions and 6 electrons make 2 manganese dioxides, okay? And 6 iodides. 6 iodide ions become 3 I2s plus 6 electrons. So now what do we got? We add these together. We've got 6 electrons on the left side and 6 electrons on the right side. And those are going to cancel, which is what we were after, which is making the electrons cancel. So then when we add those together, we now have this reaction. So 2 permanganates plus 6 iodides give us 2 manganese dioxides plus 3 I2s, 3 iodines. Now, so we balanced for charge, but we're still not done yet because we're not balanced for mass. Because we would have, if we work this out, we would have 2 times 4, we would have 8 oxygens on the left side, but we only have 4 oxygens on the right side. So we're not balanced for mass. So that's our final step. So we're going to need to add 4 water molecules to the right side to make the oxygen balance, right? That's why we add. That's where the 4 waters comes from. So now we have 4 oxygens and 4 oxygens. We have 8 oxygens here. 2 times 4 is 8 here. But by adding the 4 waters, we added 8 hydrogens. So we have to add 8 hydrogens to the left side, okay, to make it balanced. And now our reaction is balanced. Now, if we've done all this correctly, when you get to the final balanced equation, if you've done everything correctly, you should have the same charge on both sides of the equation, right? None of these are charged, right? So basically, what's our total charge on the left side? 0. Okay, and if we had 8 plus, 2 minus, and 6 minus, all that adds up to 0. So we have the same charge. We have the same charge on both sides. Now, what if we wanted to balance this for basic solution? So here's our, one more time, here's our unbalanced equation. 2 permanganates and 6 iodides make 2 manganese dioxides and 3 I2. So again, we've got to get 4 more oxygens on the right side. So how do we do this? We add to keep, because we still have to keep the we have to add oxygen yet still keep the hydrogens in balance. So we're going to add 2 hydroxides for every oxygen that's needed, and 1 hydroxide, or 1 water rather, to the opposite side. So we wind up adding 8 hydroxides. We add hydroxide to the side that needs oxygen. So we add 8 hydroxides here and 4 waters here. And that way we're still keeping the hydrogens in balance. And that gives this equation. Okay, so let's double check. Let's double check to make sure we have the same charge on both sides. Okay. All this here, 0, 0, and 8 minus, adds to a charge of -8. And what do we have over here? Okay, so 2 minus and 6 minus adds to -8. Okay, so let's do one more example. Let's make something up here. Let's look at the reaction between permanganate ion. Again, we're using permanganate. Reacts with this is commonly used as an oxidant. Let's look at the reaction between permanganate and oxalate. Okay, and that's going to produce manganese dioxide. Not manganese dioxide, rather, but manganese plus 2. Okay, and carbon dioxide. Okay, so this is a reaction that's commonly used in redox titrations. Alright, so let's figure out, first step, before we go any further, we have to figure out what our oxidation numbers are, first thing. And then we can divide this up into half reactions, right? So manganese we used in the previous example. Okay, so oxidation number of manganese is +7. Okay, for oxalate, I used this in a previous example. In the past video, we figured this out, where oxalate is carbon in the +3 oxidation number. Here we have a monatomic ion, so the charge is the same as the oxidation number, or oxidation number is the same as the charge, +2. And here we have carbon dioxide, which would be carbon +4. Okay, so let's start out by writing our half reactions. And you might want to know, out of curiosity, why is it in the last example we used permanganate as a titrant and we got manganese dioxide as a product, and here we're getting manganese too, which you get depends upon the reaction conditions. But anyway, let's balance this. So permanganate permanganate, MnO4 minus, is becoming manganese plus 2, right? So we're going from plus 7 to 2, that's 5 electrons, and it's a reduction, right? If we're going from plus 7 to plus 2, we're going to have to add 5 electrons to bring the oxidation number down by 5. Okay, so that's our half reaction for the reduction. Okay, for our oxidation, so oxalate is becoming carbon dioxide. Okay, so again, we're going from carbon plus 3 to plus 4, but it's a non-hydrogen or oxygen element. I'm going to want to balance the carbon here. So there's 2 carbons in oxalate, so ultimately we're going to make 2 carbon dioxides. And so we're going to go plus 3 to plus 4, but we're going to do it twice. We have to do it twice to keep the mass balance, so that's going to be 2 electrons. Okay, so now we have 5 electrons transferred here, 2 electrons here. The lowest common denominator between 2 and 5 is 10, right? So how do we get a balanced equation out of that? We're going to have to do that one twice. Okay, and we're going to have to do this one 5 times. Okay, so let's write that out, and then when we do that, the electrons will cancel. So we're going to have 2 permanganates right? 2 permanganates plus 5 oxalates okay, we're going to make 2 manganese 2s plus 2 manganese 2s plus 2 times 5 is 10 plus 10 plus 10 carbon dioxides. Okay, so that's our charged balanced equation. Now we're going to have to balance the mass. So we've got 2 times 10, we've got 20 oxygens there. And how many do we have here? We have 4 times 5, we've got 20 oxygens here. Okay, and 2 times 4 is 8 oxygens in the permanganate. Okay, so we have 28 oxygens on the left side and 20 oxygens on the 28 on the left side and only 20 on the right side. So we're going to have to add, we'd have to add what? We're going to have to add 8 waters to it. Let's rewrite it. So 2 permanganates plus 5 oxalates makes 2 manganese 2s plus 10 carbon dioxides, and we'll have to add 8 waters to that. Okay, and by adding the 8 waters to make the oxygen balance, we've had to add 16 hydrogens, so we're going to have to add 16 hydrogens to the 16 hydrogens to the left side, and that should be our final balanced equation. If we've done this right, we should have the same charge on both sides. Alright, so 0, 0, and 2 times plus 2, that adds up to plus 4. And let's see, we're going to have 16 plus 2 minus, let's see, we're going to have 10 minus, we have 10 minus here, we have 10 minus total there, 2 minus there, and 16 plus there, and that does add up to 4 plus. Okay, so we've got the same charge on both sides, that's it. We're balanced for both charge and mass. And we'll stop it.